Alright, so we're going to use derivatives to find the equation of a tangent. Very first question says, find the equation of the tangent. Oh, it'd been nice if I wrote the equation they want us to find for. They want us to find when f at x is equal to 1 over x. Okay? And we're also going to find it at the point of x when it equals 2. Okay? So instead of actually plugging in x at the value of 2, we're going to go about this the same way using our variable x, putting it into our first principle formula. And then after we've found the equation of the tangent, we're going to find the equation of a line perpendicular to the tangent at going through that same point when x equals 2. And this is also known as the normal. Now you guys will remember that when we went through vectors, a normal is a line perpendicular to our original equation. Okay? So we'll put this into our first principles formula once again. Our limit of h as it approaches 0, or f prime we're looking for here, say f prime x, is, and our formula is the function, so I'll write it all out again, a plus h minus f at a divided by h. We're going to plug our function into this. So our limit of h as it approaches 0. Our function was 1 over x. So we're going to be left with 1 over x plus h. X is our a value. Subtract the original function was 1 over x, all divided by the term h. Okay. We're going to now try to simplify this. So in order to simplify this, I have two fractions on top, and they're being subtracted by each other. I'm going to need a common denominator here. Okay? So we're going to have to multiply one denominator by the other's denominator, and vice versa. So what's going to happen here, we'll do it right in this step, is on this side we're going to be multiplying by x plus h, both the top and the bottom of the fraction, since that is our x plus h. And we're going to multiply the other fraction by the term x, both the bottom and the top of the fraction, so that we end up with common denominators. So our limit of h as it approaches 0 is x divided by, and we're just going to keep them separate for now, x times x plus h, subtract x plus h divided by x times x plus h, all over h. We have a common denominator, so we're going to combine these fractions, and we're going to get x subtract h. Okay. Think of it like a distributive property. We took this negative and multiplied it to both of the terms. All over, because our denominator is the same, we have x plus h divided by the term h. Our fraction is really compounding here, so we're going to try to simplify it. We know our x's are going to, so like I said, we have our x's. Our x's are both going to cancel out to make a 0. Okay? And we've canceled out those x's, so we have our negative x, or sorry, negative h will be on top now. Above. Our x times h. Okay. And all divided by our h. Now, because we have a fraction stacked like this, I'm going to try to simplify it. And this could also be written like this. We'll have negative h over x times x plus h divided by h. Remember, when we're dividing fractions, we flip and invert the second term and turn it into a multiplication question. So it's now going to look like negative h over x times x plus h times 1 over h. Okay. Now when we go to combine that, I have the limit of h as it approaches 0. And we have negative h times 1 is still going to be negative h. We're now only working with one fraction, which is nice. And when I multiply by h, well, I'm going to have h times x plus h. Right? We haven't combined any of those. And the reason we did that is so we can now eliminate our h's. And we're left with negative 1 over and instead of just leaving it like this now, I'm now going to finally distribute my x into both terms. So we have x squared plus x times h. Okay. Well, now I know if I plug in our approximation for 0, so a number infinitely close to 0 for h, I will no longer have a 0 on the bottom of the equation, so I won't have something that's undetermined. So I can now go about doing this. I take that 0 value for h and put it in here. That's going to turn this entire thing, no matter what x is, it'll turn it into 0 because h is 0. So our limit then becomes 1 over, or negative 1 over x squared as our final value for our derivatives. Okay, so that's our slope at any value of x. Now remember, they asked us to find it at a value of x is equal to 2. So when x is equal to 2, the slope of our equation is going to be 1 or negative 1 over 2 squared, which is negative 1 over 4. Okay. Now, when x is 2, we actually never went about finding out what the y value is. So what that y coordinate is in terms of the equation, not just the slope. So we're going to zoom back up. What was the equation? 1 over x. Okay, very easy. So that's our x value of some point. Our y value would be plugging x into the equation. Now remember, the equation was y over, or f at x was equal to 1 over x. When we plug x into that, when we plug x into that, we get 1 over 2. Okay. So at this specific point of 2 and 1 over 2, the slope of the curve, or the slope of the line tangent to this is 1/4, or negative 1/4. They asked us for the equation of this. If you guys remember, your equation is y equals mx plus b. B is our y-intercept. We don't know the value of that, but we do know the value of our slope. Our slope is negative 1/4. And we have a x and y value, so we're going to plug those in for our x and y in here. Our y value is 1/2. Our slope is negative 1/4. Our x value is 2. And we need to find a b value. Well, this is going to give us, I'm going to jump over here so we have some room. 1/2 is equal to negative 1/2 plus b. And when I bring that over to the other side, what is a half plus a half? Anyone know? 1. Very good. Is our b. So in our slope y-intercept form, if our b value is 1, we're going to get y is equal to negative 1/4 x plus 1. Okay? Now, in your book, they put it into standard form. They didn't ask for that, so slope y-intercept form is fine. Standard form would be okay. There's also point slope. There's many different ways to write a linear equation. Okay? That was only part A. Part B said to find a line perpendicular to that, or the normal. If you guys remember from our vectors, a normal in two-dimensional space is just going to be the negative reciprocal for part B. So the negative reciprocal of negative 1 over 4 is what? Just 4. Okay? It's going to be just 4. And they said they wanted to go through the exact same point when x was equal to 2. Well, we know that coordinate is at 2.5. We'd solved that in the previous question. So the equation of a line perpendicular to this would be y is equal to our slope still being 4, because it's perpendicular, x plus b. And we're going to take our x and y value and plug them in for x and y. So again, we're going to get a half is equal to 4 times 2 plus b. Move over here so we have room. This becomes 1/2. That's going to become 8 when we move it to the other side. It becomes negative 8 equals b. So our b value is going to be 15 over 2? Negative 15 over 2. Or negative 7.5. So perpendicular line is y is equal to 4 x minus 15 over 2. That's in, again, slope y-intercept form. They have it in standard form. Either way is fine. Oh, that's too far out.